In this course, I'm going to give you an introduction to Docker, which is a tool for creating, running, publishing, and managing Linux containers. Up until recently, most cloud platforms were virtual machine based, but the rising popularity of Docker and containerization is making it clear that the future of the cloud is containers. Before we talk about Docker specifically, let's first discuss what containers are and how they differ from virtual machines. Linux containers are considered operating system level virtualization. This is a form of virtualization that provides isolated user space instances on a single host machine. OS virtualization gives an isolated view of processes, user space, and the file system from within. Unlike other forms of virtualization, containers share the kernel with the Linux host that they are running on. Despite recently becoming more popular because of Docker, operating system virtualization has actually been around for years. Technologies such as FreeBSD jails, Solaris zones, and LXC are forms of containerization and are still used today. So what are the differences between containers and full virtual machines? This image depicts some of the differences at a high level. Both forms of virtualization require some sort of host operating system to work. Virtual machines can run on a variety of operating systems, from Linux to Unix to even Windows. Containers can run on Linux or Unix depending on the technology used. Microsoft is also in the process of adding containerization support to newer versions of Windows Server. Virtual machines require something called a hypervisor. A hypervisor is basically a piece of software that can create, run, destroy, and monitor virtual machines. There are two types of hypervisors, Type 1 and Type 2. Type 1 hypervisors run directly on the host machine hardware. ESX and Xen are popular examples of Type 1 hypervisors. The type depicted here is a Type 2 hypervisor, which runs as software on top of the host operating system. VMware Workstation and VirtualBox are commonly used Type 2 hypervisors. Containers do not require a hypervisor to run, rather they require a container engine to manage the containers. The container engine could be FreeBSD jails, Solaris zones, Rocket, or Docker. Virtual machines that are managed by a hypervisor can run any guest OS they choose, regardless of the host operating system or hypervisor. Virtual machines require a complete operating system install. Since they run a full operating system, they incur the same startup and shutdown times as if they were running on bare metal. Virtual machines can run many processes and have a variety of network configurations and file system configurations. Containers have significantly smaller overhead than a full virtual machine. This is because they share the kernel with the host operating system. This means that containers can start and stop extremely fast. Containers are typically used to contain a single process and its dependencies. And usually the startup time is determined by the amount of time the containerized process takes to start. This makes containers extremely efficient in clustered cloud-like environments where container instances can come and go at any time. One drawback of containers, though, is that they share the host operating system's kernel, and so they must use the same operating system. For example, Docker containers must run Linux distributions, and they cannot run Unix or Windows processes. Docker is a tool built as an abstraction on top of Linux containers that allows for easy programmatic creation and distribution of container images, as well as launching and deploying containers themselves. Docker provides simple command line tools and HTTP APIs that make managing containers easy to automate and creates a homogeneous system for running applications. Docker containers ship with the containerized applications dependencies baked in, so deployment becomes the same regardless of the technology or Linux distribution running in the container. In the next lesson, we'll discuss the Docker architecture at a high level.